Compared to traditional websites, 3D ones can be very demanding in terms of performance. It's important to keep in mind that most of your users don't use the same device. Some have high-end devices with a strong GPU, while others have a low-end one with weak GPU. Some can browse your website from their mobile, while some others on their desktop. You need to optimize your projects to ensure that a maximum number of users can enjoy your 3D websites. Before diving into some techniques and optimization, let's talk about draw calls. In 3D graphics, a draw call is a command sent to the GPU to tell it what to draw and how to draw it. To help you visualize it, let's install a browser extension. Its name is Spector.js. You can find the link in the text content of this lesson. Once you have installed it, go to your extensions here and select Spector.js. I don't know why, but you need sometimes to do it twice, so it opens it, and hit the record button. It contains a lot of information about what is your 3D renderer doing. You can see the number of comments in the top right, it's 314, which is quite a lot. And on the left, you have the list of each draw call. The first ones, it's only shadow. Then we scroll, what do we see? We see the character is appearing. It has some draw calls to display it. And then we have one draw call per mesh, which is not optimized at all. So currently we have one draw call to render one cube. But before having a look at how to optimize those number of draw calls, let's continue exploring Spector.js and go to the Information tab. It contains a lot of useful information to help you adjust and optimize your experience. For example, the number of comments sent to the GPU and draw, but also the number of vertices. If you are using high-end models, maybe they are not optimized and you will see huge numbers here. To render all our animated cube in one single draw call, we can use a technique named instancing. There is a dry component to help us do it easily, which is named instance. It's in the performance section of dry documentation. And what instances will help us to do is to reuse the same geometry and material for multiple objects, and it will result in one single draw call. Let's have a look at the code responsible for those boxes that is animating them. In experience component, we create an array with a defined length. Here it's 40. And for each one, it will create a box with a random position, scale, color, and speed. Then we have a map that is rendering all those boxes. And a box, the component is just on top. It's a simple mesh with a box geometry and mesh standard material, with a use frame to animate it based on its speed. So instead of isolating each mesh individually, let's use instances. So we wrap here with instances. Be sure it's the plural one. But what we want to do is to reuse a geometry and a material. So we will take them here from the box and put them in instances. So they will all use this one. But the color as it is defined inside the box, we will get rid of it here. And we will need to change our box. Instead of declaring a mesh, we will declare it as an instance. So it will be able to use the shared box geometry and mesh standard material. It's still working, but we need to apply the color to the instance. We have it as a prop here, and the instance has a color property. So we just assign it. And we have the exact same result that we had before. But let's run again Spector.js. Click here and record. You can see we have less commands. It was more than 300 and now it's more in the 100 section. If we go to information, we only have 18 draw calls. If we look on the left, what we have already the shadow and the 3D model for the character. But for the cubes, we only have one draw call. One is made for the shadows, but for all the meshes, it's only one single draw call. Let's check if it's working properly. Let's increase the number of boxes to 1000. It's a lot of cubes. Let's run again Spector.js. Record. And on the left, we can see one single draw call for this. And in Information tab, we still have 18 draw call. But even if we optimize it and it's working well on my high-end MacBook Pro, maybe it's not the case on mobile devices or on low-end laptops. To detect during the runtime if the app is running correctly with a good frame per second, we can use the performance monitor from Dry library. Let's add it inside our canvas, performance monitor. And let's use some callback functions it has. OnChange, which will be called when the FPS or the factor is updated. OnIncline, it's when the performance will go above a threshold. And OnDecline, it's the opposite, when the performance degrades. To be able to see it, let's uncomment the effects here and here. And it's an effect composer with just a depth of field. Now, if we reload and have a look at the console, you can see that we have performance incline, so it's going well. And we have the FPS of my experience on my MacBook. So let's try to push it a bit, go to experience and increase the number of boxes to 20,000. Now when I reload, it's very slow, especially because I'm recording the video. And we have performance monitor declined, and it tells us we have a low FPS. What we will try to do is to adjust the experience because we are asking too much for this device based on those number of boxes. Currently, we are using the default settings on performance monitor to call OnIncline and OnDecline, but you can adjust it by setting the threshold, and it will call OnIncline and OnDecline based on the value you want. So what we will try to do is on decline, we will disable the effects and change the number of boxes displayed in the experience. So it adjusts the experience based on what is really happening at render time. So here we can add number of boxes and use it as a prop. Now inside our app, we will create a state number of boxes and set number of boxes. We'll set it back to 20,000 like we had before. But on decline, we'll set the number of boxes by the number of boxes divided by 2. So that way it will render 10,000, but if it's called again, then it will divide it again. Let's also render our effects programmatically, so it will disable the effect if it's asking too much for the GPU. So const effect set effect is equal to useState of true. You can also go the opposite way by setting it to false and to a lower number and to increase it on the OnIncline. On decline, we also disable the effect. And we need to render it programmatically. So do we have effect? We render effects. And our experience now is taking the number of boxes, which is number of boxes from our state here. So let's try it. We have the slow loading. It's very laggy. We have decline that is called. And now it's disabling the effects and the number of boxes is lowered. You can also see on the right that after that, performance monitor incline is called. So we can re-enable the effects, but keep the number of boxes low in our OnIncline. So if after this it's going better, we can try just to put the effect back, but we keep the number of boxes low. Initially, it's laggy. It's calling decline. So we remove the effect and reduce the number of boxes. Then it goes better. So it re-enable the depth of field. And we have a nice frame per second. So it's continuing this way. But doing this to handle on decline and on incline could lead to an endless loop. For example, if we reset the number of boxes to what it was before, it will call on decline, on incline, on decline a lot of times. If you are doing something like this, you can use the flip-flops. It's the number of time it will allow it to go from on decline to on incline. And when it reaches that number, let's say 3, it will call the on fallback function, which is the end state of what it tried to do. We won't cover it, but now you know it exists. So if you end up with an endless loop, you have that solution. On this project, we play with enabling or disabling the effects or also changing the number of boxes. But of course, on your project, you have a lot of other parameters you can update to adjust the performances. For example, enabling or disabling shadows or using lower resolution of them, such as lower resolution of textures, materials, or the 3D models that you are using. Based on the screen, you also have a device pixel ratio that enhances the quality but requires to render more pixels, so you can force it to be decreased. It's a property on the canvas. You can also impact the field of view and near and far, so the less you need to render, the less it will consume resources. And it's a non-exhaustive list. Anything that could help the experience go smoothly without impacting the overall visual experience, you can play with it and find the best equation to have a good looking but also optimized experience. There are also other techniques that you can use to optimize your experience from the beginning without reacting to a fall of performances. For example, you can bake your shadows and lights. We already covered it in the shadows lesson. Keep in mind that it is a really powerful option to not consume resources at runtime. Also refer to the React hook lesson with memoization. With the use of use memo and use callback, you can avoid unnecessary render that could lead to performance issues. Same applies to use state. Avoid using it inside fast changing loops as it can cause re-render issues.